Hello everyone, I'm Huy. The project we are doing is about utilizing artificial intelligence and machine learning to play the Pong game and win it. And from that, we want to produce online teaching material of AI and machine learning. Artificial intelligence, or AI in short, from the policy papers, is an artificial creation of human-like intelligence that can learn, reason, plan, perceive, or process natural language. With the knowledge of AI, various exceptional breakthroughs have been and will have been made. Our goal is to provide a way to help an average person learn the basic concept of AI and extend their knowledge in meaningful ways. We also want to further our knowledge and build an AI model that can learn and win the Pac-Man game. There are a few reasons that the project or the improvement of AI education in general will have great impacts to the nation. The most direct impact is to help further the quality of AI and other STEM education fields. As we all know, students are usually very creative because they aren't afraid of trying new things. Therefore, any possibility could be made if more students could easily access to much the material covering fundamentals of AI. For example, in medical fields, people could be receiving faster and more efficient diagnosis before they get fatal. In finance, tracking and predicting the necessity such as stock market price had never been easier with the help of AI. Or in defense, with the machine learning models, the military could predict the enemy movement and plan their strategy.
Here's the first paper of our research. It's the Spinning Up article, and it offers a different insight on the tools and the processes that we'll be using in our algorithm. And some of the tools that it uses is Floyd Hub's deep learning platform, and it allows us to offer real-time metrics, and it offers a plotting utility for the output. So it helps us find the loss function. We can plot that real time, and the running reward, we can also plot that real time. So that'll definitely be beneficial for us to draw conclusions and overall improve our algorithm, because that's what we're trying to do. And also we want the techniques from this article to utilize things as loading and saving train policies, and also variable tracking the hyper parameterized variables.
I'm going to talk to you about the second piece of research for this project, which is image recognition through backpropagation neural networks. This process uses a trick called convolution. It uses a 3x3 matrix of coefficients for each pixel to create a whole new image. And you can see here it exaggerates the difference between pixels, making sharper edges. And it can use things like sharpen, outline, or other things. This allows it to pull the objects out, per se. So let's walk through the beginning part of this image recognition algorithm. Each frame has a different average gray value. Foreground and background image have a proportion to them. What M is multiplying the proportion of key content pixels by their grayscale value plus the proportion of background content pixels by their grayscale value. M will change gradually. Really what is happening, the proportions will change, which is R1 to R2 and G1 to G2. Then the variance is calculated. The equations can be rearranged, and feeding this in, eventually you can calculate a rough threshold. This is how it realizes what parts of the video images are foreground and background. The neural network then constantly adjusts this threshold. The DSFA algorithm then does the feature extraction. I could go on, but I soon realized that this is not necessarily effective for our AI Pong program. This process I just described is useful for complex images. In our game of Pong, the program is already able to tell right where the paddles and ball are using a different algorithm. In essence, there's no trouble with image recognition in Pong. I'd like to go from here to start researching now how to store multiple frames at a time in a Pong game to make it better.
The article discusses reinforcement learning with regards to artificial intelligence, and it provides some topics that demonstrate the success it has with AI. Reinforcement learning is a technique that machines can use to learn on their own. The computer will engage in trial and error from thousands of trials. The goal is for the model to figure out by itself how to maximize rewards. With this, AI has beaten the game of backgammon and Atari. Reinforcement learning is also used to develop autonomous cars and prosthetic legs. For example, a programmer cannot predict every action a car will do. So from reinforcement learning, the system was able to learn through obstacles and rewards from thousands of trials. With reinforcement learning, prosthetic legs can automatically recognize people's walking patterns and create effective mobility. This has only been done in the Stanford labs, as it takes a lot of trials for the machines to recognize the different leg movements.
Hi, my name is Win, and I will be talking about technical descriptions. The process of the AI algorithm will consist of 3 steps: input, training, and learning. The purpose is to let the AI algorithm to predict an action that leads to getting a score based on the current state of the game. So the first step is input. The GM library will capture a frame of the game and store it into a 2D array. The element of the 2D array is the integer values range from 0 to 255, and each frame is brought to include row 35 to 144 and downsized to 80 by 80 pixels. Any element with the value 144 or 109 are changed to 0. This allows the algorithm to identify the paw and the paddle. The 2D array is now a binary 2D array, and it will be changed to a binary vector. So we will take the differences between the current frame and the previous frame if the previous frame exists. Moving on to the training step. So the binary vector is fed into the input layer of the neural network, and the hidden layer will then compute the weight of each of the input layer and use the computed value to go through an ReLU activation function to actually calculate the hidden layer value, and the output from that will be used to calculate the actual output, which will go through another activation function to compute the probability of moving up or down of the paddles. So the actions is determined by the probability, and that action will be sent to the simulation to render the next state of the game. And the game end, an episode of the game end is when it reaches 21 points. So the game will keep computing, go through the neural network to compute the actions, and at every 10 episodes, the learning step occur. So a binary vector y set to 1 if the actions were up and 0 otherwise is subtracted by the output from the training step. The result from the subtractions is used for back propagations to improve the weight of each layers and to compute the gradient. So the output from the previous step is used to change the weight of hidden layer using linear algebra. And the previous way is go through the ReLU activation function to calculate the hidden layer, and that hidden layer value is used to compute to update weight number 1. So, and at the end of the process, we will have the gradient computed. So the gradient is optimize every 10 episodes using the RMS prop to ensure that the radians have the same size of magnitude. By using the RMS prop, we will ensure that the algorithm to convert faster and learning faster as well.
Hi, my name is Nam. After Nguyen talked about technical description, I will continue to present the technical approach of our team, which includes the specific tasks that we will follow to accomplish our program. The first one is to set up the working space in the virtual world where we put up our progress for the director to see. Next, we will implement the documentation from the last summer team. This includes the self-teach of Python, the installation of the programming tools such as Python and Git, and finally follow the document description to understand what is going on in the code. Afterward, we will teach ourselves about deep reinforcement learning. The content includes the general idea of AI, machine learning, to deep learning, and finally to reinforcement learning. Throughout this, we have to learn about some math concepts like linear algebra or probability and some general algorithms like optimizations. Then we'll move to reinforcement learning characteristics, which includes the concept of state, reward, the function of value, and the policy networks, which again involve the input, output, and hidden layers, and learning rate, and path size. Finally, we will have to learn some popular algorithms in reinforcement learning, such as the policy gradient or propagation. After having a fundamental idea of reinforcement learning, we want to improve our code using TensorFlow, another powerful library for deep learning and machine learning in Python. Then we want to put what we have learned to create an AI that play another R3 game, which in this case is Pac-Man. This step may seem vague because now we haven't had a concrete ideas of reinforcement learning concepts, but we want to do that in the future. And finally, and most importantly, we have to put what we learn into a document and transform that document into a lectures that teach high school students about AI and deep learning. So based on this technical approach, I'll talk about the schedule that our team come up later.
For programmatic risks, one of the biggest ones is communication delays between team members that could slow down our progress, since we can only move as fast as our slowest teammate. And then the repetition of work by two members if we don't have a centralized repository of what's been completed and documented is also just going to waste time in this short summer that we have. And so some technical risks are team members with different package versions for things such as OpenAI's Gym or TensorFlow can cause time-consuming bugs as a result of different features or even different syntax between the versions. And so some solutions we've identified and started to implement are setting up a Discord server to increase communication between team members. This instant messaging and organization of sub-teams is very efficient in communication. And our shared Google Drive, is also very helpful in having a central repository of what's been completed and documented. And in the future, we're going to set up a GitHub repository for our code so that we have version control. And then we're going to use Google Colab notebooks, which are basically Jupyter notebooks stored in Google Drive and run in the web browser. And they come pre-installed with TensorFlow, which will make it easy for us to build and test machine learning models and even train them using GPUs, which could significantly increase how fast they're trained. And the use of text cells alongside the code cells is going to make it much easier to document. And in order to decrease the programmatic risks, identified earlier, we're going to set up Smart Pong exactly according to the 2019 team's documentation in order to decrease any bugs. And any bugs we do find in setting up, mostly in the environment setup, will be documented with their fix in order to decrease time debugging in the future. And so in order to decrease the technical risk of package version conflicts, we're going to have strict documentation of which versions we're using for TensorFlow and OpenAI Gym in order to make sure all team members are using the same environment, which will decrease time-consuming bugs.
Hello, I'm Corey, and I'm going to be covering all the things we will accomplish over the course of the summer. Part of the benefit of recording this video a couple weeks into the project is we can already look back at some of our goals and see what we've accomplished and whether we're on track. We began work on our project at the beginning of week 2 and aimed to have last year's project up and running by the end of the week. We actually exceeded this goal, and almost all the members on our team had the project running on their computers by Thursday of that week. Now that we have demonstrated last year's project, we will begin working on studying how to apply neural networks to a different game, such as Pac-Man. The end goal for our project is for it to be able to beat out a human player in whatever game it learns. For a player versus player game, being able to beat a human, or in a game like Pac-Man, being able to gain a higher score than a player. As the summer draws toward its conclusion, we aim to prepare 10 one-hour lectures, applying our knowledge of artificial intelligence and neural networks to the world of education. The end goal is for these lectures to be used in future SADE programs to help students learn about AI and hit the ground running.
So here's our schedule based on the technical approach. In the first week, we'll get used to the virtual world and set up the working space there. Then in the second week, we'll implement the project from the last summer team. Next, in week 3 to week 7, we'll teach ourselves deep learning and simultaneously improve the code using TensorFlow. After that, in week 7 to week 9, we'll create the Pac-Man program. Finally, throughout the progress, when we teach ourselves, improve the code and create the program, we'll document what we have learned and create many lectures that high school students.
Hello, this is Akshar summarizing the project planning document for the AI Smart Pong teams. So overall, our project will be utilizing artificial intelligence, deep learning, TensorFlow, and other technologies to create an agent that's going to play the Pong game. And as of now, this it's already up and running, and the program was given input data, and it trained on that data in order to learn how to play Pong better. And what we're hoping to accomplish soon during this program is to be able to create another program that can play Pac-Man and win, so a little bit more advanced than Pong. And we're also going to create a series of 10 lectures split across both AI teams to teach students in the future about artificial intelligence. And we strongly believe that this project will add value for students across the nation because we will be explaining these concepts in a very simple manner, and we're going to be creating teaching charts that essentially for them to follow along in every step of the process in order to learn more about artificial intelligence. So yeah, thank you.